Hello. All right. I wanted to talk a little bit about velocity relativity, or aka Galilean or Newtonian relativity. So, this is an idea 400 years old that if two things are in motion, you can consider that system either as one of them is in motion, or one of them is at rest and the other in motion, or you can consider the other at rest and the one in motion. And there is no difference. That's just a choice you could make in your calculations. Now, these bodies are not accelerating. These are just drifting by each other. That was a very fruitful idea. And, people use that idea to fruitful results. Didn't have to take it literally as though it was, actually relative. Maybe it's just a way of, calculating what happens. But ultimately, there would be an absolute reference frame. Though I'm pretty sure Galileo's position was that it was real, that there really is no difference, that either one could be considered at rest. There's a lot of implications to that. There is no center or particular place in the universe that's the origin point. You're in the center. The edge of the universe is, whatever it is, 14 billion years away. And the other guy's over there, and the edge of the universe for him is not 14 billion plus 70 yards. It's still 14 billion. I once asked an astrophysicist that I worked with if there was no center of the universe or if everywhere is the center of the universe. And he said probably from the, geometric definition of center, everyone is at the center of the universe. And then he posed to me the question of, but the really thing I can't understand is if everything is all in a tiny little singularity, how could it explode? That's like saying the center of a black hole would explode, which I thought was a good point. Not necessarily related, but... So we didn't really know what that meant. When the idea of the ether came along, it was like, look, light is traveling, presumably since it's a wave, because of the diffraction effects and interference or various things that showed it was a wave, whether it was also a particle or not, it must be traveling in a medium, right? Now, one of the ways, the speed of light was triangulated on. Various people measured the speed of light, calculated things, and one was that the speed of electromagnetic wave propagation from what was known of the interaction between the electric and magnetic field, or however you want to put that, was that a wave, based on that interaction of the electric and magnetic field as the medium, was the speed of light. Now, the idea that this medium had to be there meant that we could measure our speeds relative to it. And whether it was the absolute reference frame, it could have existed and still not been an absolute reference frame any more than the fact that the Earth is a good reference frame, but it's not absolute. The surface of the Earth, you can do all your calculations about an auto accident using the Earth as the center of frame. As a matter of fact, it's advisable to look at it that way. But it's not an absolute one. That surface is also spinning through space and time. And, but still, it would be pretty good. And if it was pervasive throughout the universe and, depending on, its characteristics, whether it was warped and whatnot, it would certainly be a good candidate for something like an absolute frame. Now, that's what the Michelson and I checked it. His name was pronounced Michelson-Morley experiment, demonstrated, which I had to perform in college. And basically, by pointing lasers, and reflecting them, you can calculate if, based on the speed of the Earth, like at one place, the beam of light is fired off from where the Earth is moving. From another one, it's transverse or perpendicular rather, and so it wouldn't be affected by the motion of the Earth. And you can create a situation where these waves, if the waves arrive perfectly, then they'll interfere one way, perhaps showing no interference lines. And if this one is speeding along at a different speed because it hit a mirror that pushed it a little faster, then there would be an interference pattern. And this can be very, very precise because of the short wavelength of light, right? You don't need to nudge it very much before you could see the interference pattern. And because the wavelength of light was understood, or frequency, you could make the calculations of what it should look like and what could happen. And then doing that experiment, seeing the negative result, that showed that, every individual is at rest with the medium that light travels through. Now, they advertise this as meaning the ether doesn't exist, but whatever. Another way of looking at it is, there's a permeating medium. It's the for light. It's the electromagnetic field, which is one field, and it just happens to be three-dimensional, and maybe more dimensions for all I know. But it exists, but it's at rest with every body in an inertial frame, meaning any body that's not under acceleration, it's not falling or with a thruster pushing it faster and faster. It's at rest. Now that's weird, right? But Einstein came along and also did a thought experiment about why this sort of thing had to be true. And why, not so much that it had to be true, but that if it was true, that you would have distortion of time and space that you could measure, right? You could have very regular processes like quartz vibrations, put them change the frame, bring them back, and these are changes you could measure and predict. And if you predicted them and got them right when you measured them, that would be a pretty good sign that, And we don't understand relativity innately in our common sense because in our environment in the forests and jungles, it doesn't pertain, right? The Earth itself, the Earth is an absolute enough reference frame for apes and monkeys and mammals and all animals. All right. So it is weird, and it's something I think everybody should think about, but you're going to have to face facts that relativity and the fact that if Galileo was correct, then time and space would have to distort sometimes. And that turned out to be true by measurement, not because I thought it and it made common sense and my brain, of course, automatically knows how the universe is working. No, but because we measured it. And so it's something we have to wrap our understanding around. So, 400 years of science getting confirmed and confirmed and confirmed, I think, is something that I feel pretty confident believing in. Doesn't mean it's absolutely true. No, the whole story hasn't been told yet. But is the electromagnetic field essentially at rest with every inertial frame? Yes, that's possible. Do time, space, and mass warp and distort to accommodate, in the mathematical equations so that everything works out? Yeah, it does. Now, are there weird, unresolved paradoxes from that? Fuck yeah, that's why starting 100 years ago, we had postmodernism where we had to realize fundamental of reality is some weird shit. Don't rely on your common sense and the breath of God telling you how things are fundamentally behaving in the universe. So, for example, if something's traveling, half light speed, any speed really, then its clock is slowing down. It's slowed down for us. But because of Galilean relativity on that spaceship, we're watching from planet Orbo, we're the one moving by, and they're the ones coasting. So our clock is going slower according to them. And if you have a telescope and looking at each other will see each other as going slower. And that you can actually calculate as a potential optical illusion because of the time and space distortion all involved. Someone's traveling at that speed and the light then is traveling from further when it moves along. All that math works out that, both of them see is going slower. However, the reason it's physically true is because that's just for inertial frames. Under an accelerated special relativity, under an accelerated frame where the spaceship slows down and comes back, that requires general relativity, where it was generalized to include non-inertial frames. And the math gets very difficult. But if you do that, the one that went through the accelerated frame, that spent energy, you see, to join the other frame, because it takes energy. If you're traveling on half the speed of light and you want to land on the planet, you got to use a lot of energy to slow down, and you have to accelerate on yourself. And if you do that and you do all of the math of the calculation, time seems to slow down and speed up and do all kinds of weird things as it's looping around, and the end result is the guy that changed their frame, the person that came to your frame, that's the one that'll end up having had slower time. And the elements of this are confirmed in experiments that show there is time dilation. Yeah, someone can deny it, but you can also accept the reality. The fact that denial is possible, doesn't mean that you can't also accept reality. So I'm sorry. I wish more people realized that things started to get weird 400 years ago, except for nobody really took it literally. Like the weird part of it was like, this is the way we look at it. And it was very, very successful. And then Einstein came along and said, wait, there's some weird ramifications of this. And those ramifications turned out to be reality. So overturning that is overturning 400 years of science across the whole world, every nation and people. And the idea that they're in a big cabal because they all are the same kind of person that wants to pretend that this is possible, no. And that's the whole point too with Einstein. People were not eager to go. There were plenty of people that were like, that's woo-woo stuff, way more than Einstein. Einstein said that kind of about quantum mechanics, but a lot of people said that about Einstein. These are crazy ideas. We like Newton, where there's gears and BBs and bullets and bouncing things, billiard balls going into pockets and whatnot. Predictable forever. The establishment, the majority didn't want that. But since they have an established way of demonstrating things to each other, they had to accept the evidence before their eyes that time and space and mass all distort with velocities. The clocks don't get broken because then they've done experiments. You got an atomic clock in the ground. It has some distortion because of its gravitational well. You put someone up in a different gravitational well and go really fast, and then land one, and that was the acceleration when it landed. The one that lands and joins the ground one, it went slower. It's behind. It didn't break. You can look at it. It's just as operational as ever. It didn't hurt it. People in the space station whizzing around thousands of miles an hour, they're not breaking. And then auto repairing when they land. Right? Photons are not bullets, turns out. They're not water waves. They are in this weird relativistic medium known as the electromagnetic field. And it's a fair name because even though there's a lot of things still to learn about how it works and how it might be unified with other things, which I suspect, but maybe not, but the part that we see and call that already exists. It might be the part of a bigger whole. It might be different than we think, but it is what's behind electric and magnetic forces. And that is what a photon is an electromagnetic wave. And it runs in a sort of ethereal, relativistic medium, which we call right now the electromagnetic field. All right, cheers.